Picture this. Rain. A lot of rain, not just for a couple of days or even months, but for almost
2 million
years. Sounds like the worst vacation ever, right? Well, for the dinosaurs, this wet and wild saga was the ultimate plot twist. Welcome to the Carnian Pluvial episode, a time when dry, dusty deserts turned into lush, rainforest-like landscapes. This downpour didn't just change the weather, it sparked a transformation that paved the way for dinosaurs to rise and roar. So grab your umbrella, because this epic story of rain, chaos, and evolution is about to get soaked in history. I promise it will be one of the most informative 10 minutes of your life. Imagine Earth as one giant supercontinent, Pangaea, squished together like all the modern continents into one massive landmass. Sounds cool, right? Well, it was cool in the literal sense. The interior was a desert wasteland. No rain, no clouds, just endless dry stretches that only the toughest creatures could survive. The ocean was so far away from the land that the rain clouds couldn't make it inland. Dinosaurs hadn't quite hit the spotlight yet. The top predators back then were croc-like creatures called crurotarsans, with toothy grins and an attitude that screamed,
I am the boss here.
These croc cousins, like pseudosuchians and phytosaurs, were the nightmare fuel of the day, ready to snap up anything that wasn't quick enough to escape. While these ancient were the top carnivorous rulers of the land, the diapsids, which were the early lizards and snakes, were just starting to make their mark. But the real show stealers were the herbivores like the famed rhynchosaurs, a chunky lizard with a parrot-like beak and cheekbones that would make influencers jealous.
Oh my god, oh my god!
Alongside them you had the dicynodonts, which were very abundant. One species, Lystrosaurus, was so common, its ubiquitous fossils helped prove plate tectonics. Talk about making an impact. Just as these creatures had figured out how to survive in the harsh, dry world, something was about to throw everything off track. Rain. Lots of it. Not just a little drizzle here and there, but a non-stop 2-million-year downpour everywhere. You'd be surprised to learn that a drastic change like this in the climate was not because of what was happening outside of the Earth, but rather what was happening inside it. Beneath our feet, Earth is anything but stable. Picture a fiery underworld, a swirling cauldron of molten rock and energy that doesn't get nearly enough credit for shaping the world above us. The crust, what we call solid ground, is actually ridiculously thin. Beneath it, hot magma plumes rise from the core until they smash through the crust. No fault lines or continental boundaries stop them. They just barge their way up. When these plumes finally break through the surface, what happens next isn't pretty. It's volcanic chaos. Flood basalt eruptions, so they are called, don't explode like the volcanoes you see in movies. Instead, they're slow, relentless lava floods that pour over vast areas for millions of years. The result? Massive stretches of basalt rock that are hundreds of times larger than any supervolcano. Flood basalt eruptions have been prime suspects in some of the Earth's deadliest extinction events. The Great Dying, for example, saw ocean temperatures soar to a lethal 40 degrees, wiping out 90% of marine life. While Hollywood loves to focus on asteroid impacts, these volcanic events are the real silent killers. They're slower, less dramatic, but far more destructive. But not all flood basalt eruptions are world-ending disasters. Some, like the Wrangelian Large Igneous Province, set the stage for major transformation. Instead of a fiery apocalypse, it brought on a climate makeover, turning a dry, barren world into a lush, rain-soaked haven. The Carnian Pluvial episode, or That Time It Rained for 2 million years. And it paved the way for life to thrive, most notably the dinosaur. From desert to rainforest, it was like Earth won the climate lottery, all thanks to the continuous flow of magma beneath our feet. Now that we know what sparked this wild event, let's take a look at when it all began. Around 235 million years ago, Earth had a volcanic meltdown in what's now Alaska and British Columbia. The Wrangelian eruptions lasted over 5 million years. By the time they were done, they had covered the land with an astounding 6 kilometers of solid lava. Imagine stacking 68 Eiffel Towers on top of each other, each one made of molten rock. But the real drama wasn't just the lava. It was what these eruptions unleashed into the atmosphere. Volcanoes are like the Earth's safety valve, releasing suppressed carbon dioxide from deep inside the mantle. But the Wrangelian eruptions did something even crazier. They introduced magma, superheated to a sizzling 1,600 DC to massive, undisturbed coal beds buried deep underground. Coal beds are essentially ancient rainforests, compacted and fossilized over millions of years, locking away vast amounts of carbon. When these beds were suddenly ignited by volcanic heat, they didn't just burn, they released that stored carbon back into the atmosphere in a catastrophic surge, along with huge amounts of other greenhouse gases and particulates into the air. All these greenhouse gases then trapped the sun's heat, giving Earth's water cycle a major boost. Normally, the sun heats the land and oceans, causing water to evaporate, rise, and then fall back to Earth as rain. But when you supercharge that system with greenhouse gases, everything speeds up. Water evaporates faster, clouds form quicker, and the rain, it becomes heavier and more widespread. It's like Mother Nature cranked up the thermostat and forgot to turn it down. The volcanic activity created the perfect conditions for life to evolve and thrive in new and exciting ways. Species that once thrived in dry, arid environments had to adapt fast to a wet, humid world that was suddenly and dramatically different. Although some species disappeared, they were quickly replaced by others better suited for the wetter, more humid world that was emerging. Alongside carbon dioxide, the eruptions released a pungent gas, hydrogen sulfide, which didn't just fill the air with a rotten egg stench. It reacted with water and oxygen, unleashing acid rain that not only caused heavy runoff, but washed away minerals and dissolved rocks like limestone. Over time, this carved out cave systems, which became brand new homes for life to exploit. The runoff eventually reached the seas, turning coastal ecosystems upside down, taking down about 30% of the marine population. The land, too, was undergoing a major transformation. As the climate became wetter and the landscape transformed into a lush green paradise, the small, soft ferns that once dominated the land were replaced by towering, woody conifers. These towering trees weren't exactly on the menu for Dicynodonts or rhynchosaurs, which had trouble eating anything too tough, and with those herbivores struggling or vanishing, their carnivore counterparts, like the cruratarsans, were left scrambling for a new food source. All of these species gradually faded into extinction. In the blink of an evolutionary eye, the entire ecosystem was undergoing a major reset. But that's where the dinosaurs, those hardy, adaptable newcomers, stepped in. Did the rain help the dinosaurs thrive? Well, we can't say for sure. What we know is they quickly exploded in numbers in an evolutionary coup. For the next 3 to 4 million years, they went from being background players, who didn't account for even 5% of fossilized vertebrates, to ecosystem dominators, making up over 90% of fossils. One of the earliest dinosaurs to seize this opportunity was Herrerasaurus. A 6-meter-long, 300-kilogram predator, it roamed what is now South America, particularly in the Ischigualasto Formation, a volcanic floodplain covered in dense jungle and warmed by the humid post-rainfall climate. As the rains transformed the world, Herrerasaurus hit the jackpot. With the shifting climate, its habitat spread across Pangaea, creating literal oases, slush, untapped areas free from competition. These new frontiers allowed Herrerasaurus and eventually other dinosaurs to expand and thrive by the time the rain stopped. This leads us to an intriguing question: how did the rain stop? It appears that when carbon levels go through the roof for a long time, Earth has a natural cleanup crew. Plants absorb the excess carbon, storing it in their tissues, while weathering and erosion help lock it away in rocks. The oceans also get in on the action, soaking up some of that carbon and eventually forming carbonate rocks like limestone. So, when the Wrangelian eruptions slowed down and eventually stopped, the carbon cycle kicked into gear, helping to restore balance to the atmosphere. Slowly but surely, Earth's climate began to shift back to its pre-rainy state. By the time the eruptions stopped around 230 million years ago, the world had settled back into the classic hot and dry Triassic conditions. The heavy rains had stopped, but the effects of the 2 million years of rainfall were far from temporary. The changes it caused were permanent. Take the conifers, for example. These plants had thrived in the wetter climate and continued to diversify, eventually laying the foundation for the pine trees we know today. Okay, wait. So this relentless monsoon was so long ago and we still know about this? How? Well, it all started in the early 1990s when two British geologists stumbled upon rock layers that didn't quite fit the dry, dusty Triassic world they expected. Instead of the usual red sandstones and dry deposits, they found thick layers of river rocks, ancient lake sediments, and even traces of coal swamps, clear signs that massive rainfall had been falling for millions of years. At first, the idea was met with skepticism. Couldn't these rocks just be from big local floods? But as time went on, strange reports from around the world started to pop up. Coal deposits in Austria, ancient lakes in Italy, wet soils in Utah, and giant rivers in China. Everywhere seemed to be pointing to the same conclusion. A dramatic increase in rainfall between 232 and 234 million years ago. Eventually, scientists realized this wasn't just a local event, it was a global one. This period became known as the Carnian Pluvial episode. And boy, did it rain. A lot. Thanks for watching, and don't forget to like, subscribe, and hit that bell, because if there's one thing we've learned from history, it's that you never know when a little rain might come along and change everything.